All right, next up here, we're going to look at factoring some higher powers. So when you are factoring these higher powers, you want to just make sure that the exponents are in the correct pattern. And so the correct pattern, and I would write this up here, is a times x to some number right here. So I'll go ahead and use, I don't know, let's use p since it's a power. Here, I'll try to write that more neatly. Okay, and then it would be plus b times x to that power divided by 2, and then plus c. And so you know that our normal pattern for factoring here is the second power here, and then this is the first power. So the second power cut in half is the first power, and then we have that number out back. So you can see that 20 and 21 really fit that pattern as well. We have some power up front, half the power here, and then no power at all. Some power out front, half the power here, and no power at all. So we can use our same factoring technique here. And so I'm going to go ahead and use my x here. So a times c up top is going to give me 27. B on bottom is negative 12. So I can think of the numbers that multiply to make 27. I know 3 and 9, and that's it. So negative 3 and negative 9. And so I'm still going to use my grouping technique here, especially on these higher power ones. I really think it helps. And so we'll split up this middle term according to these numbers here in whatever order you want. But in this case, it's going to be negative 3x squared minus 9x squared. And the reason that is just remember what we're doing here. We're splitting up this middle term. And so before, when this was an x, of course, we just put negative 9x and negative 3x. But when it's x squared, it's got to split up like that. So then we'll keep the front, x to the fourth there, and then the back plus 27 back there. So now I'm going to group these up. And then the first group, I can take out x squared, which leaves me with x squared minus 3. The second group, I want to take out a negative 9 since the first term is negative, so that gives me x squared minus 3 as well. Good news that I get the same thing in both parentheses because that means this technique has worked. And so I can make one parentheses for the stuff outside, x squared minus 9, one parentheses for the stuff inside, x squared minus 3. And then actually I see here, and you should always kind of double check this when you're at the higher powers, can you refactor one of these? And I notice that this one right here is the difference of two perfect squares, so I can break that down as x plus 3x minus 3. Negative 3 is not, or 3 is not a perfect square, so I cannot factor this one anymore. So I'm just going to go ahead and leave it like that. Let's see. Oh, really quickly, if when I was back here, I could always double check this. If you FOIL it, x squared will give you x to the fourth. Negative 3x squared and negative 9x squared gives you negative 12x squared. Negative 9 times negative 3 is positive 27. And then remember, we can only split this last one up if it's the difference of perfect squares. So if that was x squared plus 9, I could not do that. And then once again, this one I could not do because it was not a perfect square. All right, same idea here for number 21. So I'm going to start off with the x. So in this case, I'm going to do a times c is negative 10, and then b is 3. So that is going to be, let's see, what is that? Oh, it's 5 and negative 2. So once again here, I'm going to split up this middle term by doing 5x to the third and negative 2x to the third, since that's now a third power in the middle. I'm going to keep the 2x to the sixth up front and then the minus 5 out back. Now we'll do our grouping here. So the first group, I can only take out x to the third, which leaves me with 2x to the third plus 5. And then the second group, it looks like I cannot take out anything. Now, anytime it looks like you cannot take out anything, you have to take out either a 1 or a negative 1. So in this case, since that first term is negative in that group, we're going to take out a negative 1, which leaves me with 2x to the third plus 5. All right, so now we'll make our groups here. So we have x to the third minus 1 for the outside, and then 2x to the third plus 5 for the inside. Now, there is actually another step I can do here. I can actually refactor one of these some more. So if you want to pause it right now and see if you can find the one to refactor and refactor it, go ahead and pause it right now. All right, so the one I see I can factor is this one, and what this one is perfect cubes. Remember, for perfect cubes, we can do them whether they're a sum or a difference. This one happens to be a difference, but I could do it if it was plus. 1 certainly is a perfect cube. So I'm going to leave the 2x to the third plus 5 alone for now, and I'm going to factor out the x to the third minus 1. And so the cube root, and you take away the cube on each of those, so that's going to be x, and that's going to be 1. And then to go over here, I'm going to do x times x is x squared, x times 1 is x, and then 1 times 1 is 1. And we'll do our SOAP here, so it's a minus, and so we'll go same, opposite, always positive. So that's my full factored form there. Oh, one more note here. After the SOAP, after the perfect cubes, this one should never factor, this trinomial. If you try an x on it, you try to think of two numbers that multiply to 1 and add to 1. There's no numbers that work. You can think 1 and 1, but those add to 2. You can think 1 and 0, but those multiply to 0. So it's not going to work. There's no numbers that work out. Now, I will tell you that if you find numbers that work out in this x for after the perfect cubes, the SOAP, that means you did the SOAP wrong. So go back and check your SOAP because it should not work. All right, last one of this set. So number 22. This one is not a trinomial, so I'm not worrying about kind of this pattern up at the top here. It's just difference of perfect squares. And so I'm going to break that apart into 2 parentheses. So this is going to become 4, and that's going to become 9. I think that's the easy thing to see. The little more challenging thing to see is the 8th power there. That's actually going to become 4th power and 4th power. If you kind of think a bit about it, and I'll go ahead and do my 1 plus and 1 minus. Remember, for perfect squares, we can always check it with a fl. So if I do first times first, that's going to be 16 for the 4 times 4, and then the exponents add to make the 8. And then obviously 9 times negative 9 is negative 81. All right, but once again, I noticed that one of these breaks down more. It's this one because it's the difference of perfect squares. So that's going to become 2x squared plus 3, 2x squared minus 3. And then this one does not factor anymore. All right, next up we got a brand new idea called u-substitution factoring. Very popular factoring technique, and then also a popular technique in AP Calculus or any calculus class you take. And so the key with u-substitution factoring that you may be seeing here is we're seeing this kind of thing in a parentheses that's showing up multiple times within a problem. Now, remember I said that factoring is rewriting stuff in parentheses. And so you may think, hey, Mr. Berry, these are already factored. But I also said those parentheses are multiplying by each other. So this x plus 5 is not multiplying by that x plus 5. They are subtracting, actually. Same thing here. These are subtracting, not multiplying. So whenever you see this, we are going to use something called u-substitution factoring. And so u-substitution factoring means we're going to let in a new variable here that's really not part of the problem. And so we're kind of making this up. It's kind of arbitrary. They use u, but technically you could use any variable you wanted to. And so the key is that u gets to be whatever you want it to be. And so you're usually going to do kind of whatever is the thing in the parentheses that's showing up here. So in this case, I'm going to let u equal x plus 5. And so now I'm going to rewrite this expression, but every time I see x plus 5, I'm not going to write x plus 5, I'm going to write u. And so I'm going to say x times u minus 9 times u. So you can see I replaced this x plus 5 right here and right here as I rewrote it with a u. Now, next thing we're going to do is we're going to factor with the u's. And so you got to use all your same factoring techniques. And so the first thing you should always check is GCF. And in this case, we do have a GCF. You can see that both of these terms have a u. And so we can do one of my favorite techniques here, which is GCFU. We can take a u out front, and if we take a u out front, it becomes x minus 9. I don't see any more factoring I can do, and so I'm going to now, since I'm not done with the problem now, because remember, u is a made-up thing. It's not really part of this question, and so once I'm done factoring, I'm done with u. And so my last step is to plug back in what was u originally. Oh, u was x plus 5. So now I'm going to say x plus 5 times x minus 9. And I am done. Now you can see I'm factored here because I have 2 parentheses that are multiplying by each other instead of subtracting. All right, same idea here on number 24. So on this one, we're going to let u equal 5a plus 1. And so then this becomes 2u squared minus u minus 3. I don't see a GCF here, and so I'm going to go ahead and just jump into my, my x factoring technique. So I'm going to have a times c here. Oops, not 6, it's c, which is negative 6. I was probably thinking ahead of myself there. And then b is negative 1. And so I would use negative 3 and 2, or you kind of have to in some order. And so now we're going to use that to split up this middle term. So negative 3u plus 2u. Got 2u squared there, minus 3. Now I'll do my grouping. So the first group, I can take out u, which leaves me with 2u minus 3. The second group, it looks like I cannot take out anything, so I have to take out either 1 or negative 1. And in this case, I'm going to take out a positive 1, which leaves me with 2u minus 3 in there. You do have to show that 1 because now, when we make our parentheses, it's going to be u plus 1 and 2u minus 3. Okay, remember I am not done yet because I need to plug these back in. And so I'm going to plug back in the 5a plus 1 that the problem started with. So this one's going to be 5a plus 1 because you can see this one was a 5a plus 1. Now on this other parentheses, there's a 2 multiplying in front of that u. And anytime there's a number multiplying in front of the u, you have to, I show this in a bracket, and I'm going to put the 5a plus 1 right there. And what we're going to have to do next, and I'll keep that minus 3 out back, is we're going to have to distribute that 2 in there. So always be careful anytime there's anything multiplying in front of your u, that you go ahead and distribute whatever that is into there. So over here, it's going to be 10a plus 2 minus 3, which will simplify to 10a minus 1. And then this one's going to be 5a plus 2, just combining those like terms, and there's my fully factored form. All right, a couple more u substitutions here. So on number 25, another u substitution, but it's kind of weird here because we have 2 different variables, and so, or not variables, but 2 different expressions. So what I'm going to do is I'm going to let u equal x minus 1, and then I'm going to bring in a new variable here. And so I'm going to go ahead and use, I'll go ahead and use M for my new son, Miles. You can use whatever you want. You could use whatever your name starts with. Remember that these are arbitrary, right? So honestly, you could use whatever ones you want for both of those. A lot of times in calculus, I'll use V as a second variable there. I don't like that because my U's and my V's, I might get them mixed up. So I'm just going to use M. And so now what this looks like is u squared minus m squared. And so how can we factor that? Well, there's no GCF, but what I do have is I have the difference of 2 perfect squares. And so I'm going to go ahead and write that as u plus m times u minus m, just the difference of perfect squares there. Well, I don't see any more factoring I can do, so I'm going to plug these guys back in. And so this is going to become, let's see, what is u? U is x minus 1, so x minus 1 plus, and then m is x minus 4. And then over here, we have x minus 1 for u minus, now in this case, we need to do our bracket because there's something in front of that m. There's a negative that we need to distribute. So anytime there's a number or a negative in front of one of your variables, you got to distribute that back in. So I'm going to send that in. This is going to become x minus 1 minus x plus 4. And so that's going to become 3. The x is canceled out, and then I combine the like terms. Over here, we have 2x minus 5. And so here we go. This is in factored form. I do not want to distribute the 3. Remember that the idea behind factoring is to create as many parentheses as possible. So distributing the 3 would actually be simplifying. So I want to have it factored, so I'm going to put the 3 out front and just call it, you can rewrite it like this. So 3 times 2x minus 5. All right, next up here, number 26. So this one will only need to use x squared minus 8x for u. And so that would be u squared minus 29u plus 180. So now I'll use my x here, and we'll go 180 and negative 29. And let's see, what is 180? So I can do 10 and 18. That does not work. Oh, if I do 9 and 20. that does work. So negative 20, negative 9. And so I can split this up. It'd be negative 20u, negative 9u, plus 180. And then we'll group these up. And so you pull out a u, get u minus 20. Pull out a negative 9 and get u minus 20 as well. So u minus 9, u minus 20. Now, some of you notice that that's just the same numbers that are here. So you can actually do a shortcut. If a is 1, if you have no number out front of your leading coefficient there, then you can do a little shortcut and just make these two your numbers back here if you want. It does not work, though, if you have a different number out front, so be careful. I like to just be in the habit of doing that every time. Okay, so we're not done yet. We need to plug back in our u, which is x squared minus 8x minus 9. And in this case, it'll be minus 20. And then it looks like we can factor some more. And so this one, it'll be multiplying to negative 9 and adding to negative 8. So that's negative 9 and 1. Now in this case, since I have that 1 out front, I'm going to go ahead and use my shortcut. So I'm going to say x minus 9, x plus 1. And then same thing over here. I can use the shortcut again. So then that becomes negative 10 and positive 2. So x minus 10, x plus 2. All right, next up here, it says when you are asked to factor an expression with 4 terms, try factor by grouping if the ratio between the first and the second terms is the same as the ratio between the third and the fourth terms. So we've already been doing a lot of factoring by grouping, actually, so just kind of continuing on with that. And what I mean by the ratio here is you can see that these coefficients have a 3-to-1 ratio, and these actually do as well. Negative 12 divided by negative 4 is 3-to-1. This one would be a 1-to-2 ratio, as would that one would be right there. So we'll just group it up here. So the first group, we can take out an x squared, leaving me with 3x plus 1. The second group, since it starts with a negative, we'll take out a negative 4, which also leaves me with a positive 3x plus 1. Very important, we got the same thing in both of those parentheses. So now it's x squared minus 4 times 3x plus 1. But very often in pre-calculus, once we do our factor by grouping, it will actually refactor after that, and I see that that's the case here. So we can break apart this x squared minus 4 to x plus 2x minus 2 with the difference of 2 perfect squares times 3x plus 1. All right, similar idea here on number 30, so we'll just group these up. So we take out the x to the third, and that'll leave me with x plus 2. And then the second group, it looks like we cannot take anything out. Whenever that happens, we must take something out, so we're going to take out a 1. And that'll leave me with x plus 2 there. And so now we're going to have it as x to the third plus 1 times x plus 2. However, once again here, we see that we can refactor one of these. This one is the perfect cubes here. So I will factor that as the sum of perfect cubes. Remember, for perfect cubes, you can do a sum or a difference. So I'll do x and then 1. And then I do have this x plus 2 is just going to stay put back there. But over here then, I have the first thing times itself. X times x is x squared. Then I do x times 1 is x. And then 1 times 1 is 1. All right, and so then I'll use SOAP for my pluses and minuses. So this one's a plus, so it's same, opposite, always positive. So there is my fully factored form there. All right, next up here, we're going to get into some really tough ones. And so for this one, I am going to go ahead and I see a bunch of kind of crazy stuff in parentheses here. Really, I only have 2 terms. There's a plus right there. So I'm going to use some u-substitution here. So let u equal x squared minus 5. And then I also see I have that x plus 3 in parentheses. So I'm going to pick another variable for that. I will go with I'll go m again. And we'll go x plus 3 there. So then I would rewrite this as 4 times u to the third, m to the third, plus, and then you'll notice I didn't make a u substitution for the 2x right here because it didn't have an exponent. And so I'm actually just going to multiply that 2x with the 3 out here. And so that's going to give me a 6x. And then I have u to the fourth, m squared. All right, so now we're going to start factoring. So I'm going to see what I can take out front. So I see I can take out front 2. I can take out u squared. oh, pardon me, I could take out u to the third there. Okay, and we could take out m squared, and that's going to leave me with 2m plus 3xu. We can double check that with a quick distributive property. So 2 times 2 is 4. U to the third is right there. M squared times m gives me m to the third. Then over here I got my 6. U to the third times u is u to the fourth. The x is right there. And then m squared will just attach out back. All right, I don't see any more factoring we can do, so we're going to plug back in. So I'm going to call this x squared minus 5 to the third, x plus 3 squared. Just plugging in right there and there. And now in here I need to be really careful with my brackets. So I'm going to do 2 bracket x plus 3 for m plus 3x bracket x squared minus 5. So I'm going to leave these guys out front alone for now. I'm just going to bring them down, but I need to do some work in here, so I'm going to distribute that. So it's going to be 2x plus 6 plus 3x to the third minus 15x. I'll just combine like terms there, so I get 3x to the third minus 13x plus 6. I can't do a trinomial factoring on that because of the third power up here, so I'm not even going to try. That would have to be squared in order to do that. So I'm just going to bring these other guys down. I definitely don't want to expand any of these pieces, so I'm not going to like write this 3 times and then expand it out, because I wanted factor form, so you could see all of this is factored. It's like a bunch of parentheses multiplying by each other. So I am done. All right, last up here, we'll take a look at number 32. So for number 32, I'm going to use some u-substitution again. I'm going to let u equal 2 plus x. And so this looks like u to the negative 2/3 power times x plus u to the 1/3 power. All right, so now we'll factor this. So there's only 2 terms, so we just do GCF. The smallest power of u is the negative 2/3 power. Remember, anytime you have a negative exponent, the bigger negative is the smaller exponent. And so this first term is just going to turn into x. And then this one, I'm going to do what I had, which was 1/3, minus what I took out, which is negative 2/3. So it's actually going to add together and give me a 1. And so that's just going to be plus u. All right, I don't see any more factoring I can do, so I'm going to go ahead and plug back in here. So it's going to be 2 plus x to the 2/3 power. And then this one will become 2 plus, no, it's not. It's x plus 2 plus x. I don't need to use brackets around the u this time because there's nothing in front of it multiplying. And so I'm just going to simplify this. Oh, shoot, this was the negative 2/3 power, excuse me. I'm just going to simplify that to say 2 plus x to the negative 2/3 power times 2x plus 2. However, I actually see that that's not done, so I'm going to write my final answer here. Since it wants fully factored form, I'm going to go ahead and take a 2 out. I'm going to move it all the way to the front, and then we're going to call this x plus 1 here. So this is how I would write my final answer. Now, some of you may see that negative exponent and say, hey, Mr. Berry, can we write it with that moved down to the bottom? The answer is definitely yes. If you just move that piece down to the bottom, I would accept this as an answer as well. So I'd say either one of those two.